Welcome to the Explainer. Ever wondered what a real cyber internship project actually looks like? Well, today we are breaking down a hands-on assignment from start to finish. By the end of this, you are going to have a complete blueprint for your very first cyber automation project.
So, here's our game plan for today. We'll kick things off with the mission, pick the right tools for the job, then build and test our defenses. After that, we'll cover how to package it all up, and finally, talk about what it takes to earn that project badge.
Okay, let's dive right into our mission, automating defense. The first step in any project is just getting the briefing and really wrapping your head around the core objective.
And here it is, the core challenge. You're not just reading about theory here. You're actually building real automation that does the work of both the blue team, those are the defenders, and the red team, who act like ethical hackers to test those very defenses. And the best part? It all happens in a safe, totally controlled lab environment.
To pull this off, you'll be using two of the most fundamental scripting languages out there, PowerShell for Windows and Bash for Linux. You're going to use them to create scripts that can spot threats, lock down systems, and even simulate attacks to test your own work. This is exactly what goes on in a real Security Operations Center, or SOC, which is basically the cybersecurity command center for any big company.
So now that we have our mission, it's time to choose our tools. Before you can build anything, you've got to know which tool is the right one for the job, right? What's so interesting here is just how perfectly these tools are designed for their environments. PowerShell is the absolute king of Windows. Why? Because it's baked right into the operating system, giving it this deep, special access to read event logs and check critical system settings. Then you have Bash, which is pretty much the universal language for Linux and macOS. That makes it perfect for digging through text logs and managing servers, especially all the stuff running in the cloud. And here's a security concept that is absolutely critical. Attackers love using tools like PowerShell because, well, they're already installed on the computers they're targeting. This whole technique is called living off the land, and it helps them blend in and avoid getting caught. And that is exactly why you, as a defender, have to master these tools first. You need to know them inside and out, not just how to use them for good, but how to spot when they're being used for bad. All right, enough talk. Time to get our hands dirty. This section is all about your defensive tasks, what we call the blue team stuff. This is where you'll write the actual code that's going to protect your systems. So your first assignment is on the Windows side of the house. You're going to build a PowerShell script that acts like a junior security analyst. It'll scan the logs for signs of a brute force attack. That's what Event ID 4625 is all about. It'll also check if the system is properly patched and if the antivirus is up to date. And then for the final step, it will simulate a call to an EDR. That's an endpoint detection and response tool, basically telling it to quarantine the machine if something looks off. Next up, we're jumping over to the Linux environment. Using Bash, you'll become a bit of a digital detective, hunting through authentication logs to find any IP addresses that have a suspicious number of failed logins. You'll also write some code to check for outdated software. And then, as a final defensive move, you'll automatically add those shady IPs to a firewall blacklist. Pretty cool, huh? And this just perfectly illustrates the other half of the security equation. It's not enough to just build defenses, you have to test them. This is where you get to put on your red team hat and safely simulate an attack. The goal here is to think like an attacker, but in a completely safe and reversible way. You'll create a scheduled task to mimic how malware sticks around on a system. Then you'll generate a whole bunch of failed logins to see if your brute force detection actually works. And finally, you'll create a fake file to simulate an attacker getting data ready to steal. All of this is designed to do one thing: trigger the very alerts you just built. I cannot stress this enough. Safety is, without a doubt, the #1 priority. These emulation scripts are for learning and testing inside a virtual machine or an isolated network. You never, ever run these on a real production system or a network you don't own. The goal here is to learn, not to cause any damage. So, you've built your defenses, and you've tested them. Now what? How do you present all this work like a pro? Let's take a look at how you package everything up for evaluation. This is where you connect your scripts to the bigger picture, the whole security workflow. First, you'll write a detection rule. Just think of this as the if-then logic that an analyst would plug into a SIEM. That's a security information and event management tool to automatically spot the bad stuff. Then you'll write a simple playbook, which is really just a checklist of automated steps to take the moment that alert fires.
And there it is, your complete submission package. You've got your blue team scripts, your red team script, the detection logic, the response plan, sample logs to prove it all works, and a short presentation to explain it all. See, this isn't just some homework assignment. This is a real, tangible portfolio piece. So, how is all this work actually evaluated? And, maybe more importantly, what skills will you have proven you have once you finish this whole project? Take a look at how this is graded. It's weighted just like it would be in the real world. Does your code work correctly and safely? Yeah, that's number one. But look at what's almost as important: how clear your detection rule is, how safe your emulation is, and how well you document and present your findings. Clear communication is absolutely key. Completing this mission successfully gets you the blue/red Automation Engineer badge. But honestly, forget the badge for a second and just look at those skills you've earned. These aren't just buzzwords. These are the exact keywords that recruiters and hiring managers are searching for on LinkedIn and resumes right this very minute. And that's the real prize here. When you walk into your next interview and they ask, "So, do you have any hands-on experience?" You won't just say yes. You'll show them. You'll show them the code, the detection rule, and the playbook that you built. You'll show them this project. So, we'll leave you with this to think about. What's more valuable in the long run? Building the shield or simulating the sword? And how do you take a brilliant idea from a single script running in a lab and make it work across thousands of computers in a global company? The answers to those questions, well, that's what separates a good analyst from a great one.